Okay, so one of my favorite things, and I've kind of talked about this in some of my other videos, is taking student ideas and starting to show how you can begin to model some of these things. So here's again another example of a design concept that a student shared with me, and it simply started just from a sketch here, right? So looking at this idea, we're just going to focus on this portion of it, but you'll see that it's a kind of cool approach where, again, whether it's sketches or other models or any kind of representation of how do we start to produce that as a digital 3D model. And so here we can again kind of see some variation of that. Again, there's kind of a nice gradual slope to these two different levels. Obviously, I've made my own kind of revisions and changes to this. You're going to see that there's this option where I've kind of kept this almost roof on top of it, or the ceiling or covering. I'll show you another option if you want to kind of repeat that pattern over the entire thing. It's really easy to do in that case. The only thing that you'll need for this to actually work as well is the Weaverbird plugin. So that's what gets us this very kind of round and beveled edges, so it's not as hard. So it has again kind of that more softness to it. And the script again isn't that comprehensive. What's great about it too is that it actually responds pretty nicely without requiring a whole lot of computational processing power. So that's another great thing with this kind of plugin too, is that it gives you some good variations and very adaptable. So I'll start off by just showing you what you have to do in Rhino. So the idea is that you're creating this form first using the rail or the sweep to command, or the component in Grasshopper. So you can see that we have these two rail curves which are pretty much symmetrical, or I should say mirrors of each other. And then I have three cross-section curves, and you can obviously have as many as you want or as little as you want. It really doesn't matter. The reason I have three is so that I can have some variation in that sweep as well. And it's not a huge task to do that either. What I usually like to do is use the control point curve, and I'll start off maybe kind of giving myself a couple points so that way I have again that variation to it, and then I can always turn my points on and always adjust it that way. So that's kind of one of the easiest things or easier parts to do for that, is to do that way. And then I'm also going to mirror it, so that way again it's nice and symmetrical. Again, it doesn't have to be. And then I can take that. And the only thing I want to make sure is that my direction is the same for both. So as long as I do DIR and I see that they're both going in the right direction, that's all that really matters. We also want to make sure that we select these curves in the correct order. So what you want to do is when you're creating the actual thing in the script, that you'll have to do some kind of organization of it, because it's sometimes a little counter intuitive to what you might think it is. So like I said, we'll go ahead and get started with this. So like I said, we want to use the sweep too, so I'm going to reference one curve, copy and paste and reference the next one, and then I want to reference my three cross section. It's like I said, it's one of those things where it's a little counter intuitive. If I actually, let's just go ahead and show it like this. If I select them like that, say set multiple curves, and let's see if we can create a surface from that. So freeform, sweep to, so our first rail, our second rail, and our section or profile curve, right? So you want to definitely make sure you do that in order. So if I were to have selected it this way, say set multiple curves, oh, it looks like it's okay. So it looks like I did it in the correct order anyway. So you'll know if it's wrong because you'll have some weird kind of overlapping, but that did it very nicely to get to that general form. So in order to get that kind of interesting opening with that surface is that we're first going to start using the Voronoi component, but it's one of those things where the Voronoi, in order to get this one to work at least, is that you do work with just a planar surface in order to get it to work. And so we want to kind of follow some very specific parameters, because at the end we're going to morph what our planar surface is onto this surface. So we'll take this surface now and find the dimensions. So we'll get our u and our v values, and we'll use those to create a planar surface. So basically u means x and v means y. And so you can think of this new planar surface that's been created as basically a unrolled or flattened version of that. So I'm just going to turn off some of these things. So there you go. And now we want to take our surface and start to populate it with some points. So I'm going to go to Vector, Grid, and Populate Geometry. And for this to, again, kind of have that outcome, we want to start off with a very modest amount of points so that they're large openings. So you can see I've got just a couple points. I can also include a seed slider so that I can change some of the variations of this. Right, so I can just look at all sorts of different randomization of points. Now we can actually create our Voronoi pattern. So I'm going to go to Mesh, Triangulation, and I'm just going to use the, like I said, Voronoi component, not the 3D one. So it's asking for points, so that's this. You're going to see that it goes way off of our canvas, but luckily we can add a boundary curve, which is basically just this. So now that all kind of sticks and gets trimmed to that. Like I said, if you want them to be smaller or larger, you can always add more or less. It's one of those things where everything's going to seem very abstract at first, especially when we begin to add some other parameters to this. So now that I have this, I can begin to create my interesting pattern. And this is where we're going to jump right into the Weaverbird plugin. So if I go to Weaverbird, you're going to see we have all these new tools for us. And we're going to focus on the items over here. So I'm going to first go to Transform and use the Weaverbird picture frame. So this is basically going to create an offset surface. So if I turn this off, you'll see that now we start to get this, and it's slightly kind of non-uniform, and it's offsetting, which is fine. We want to make sure again that we have some of these done correctly. So I usually stick with the %, so I keep that at 0, but I do want to create a number slider for that value. So I'm going to just again create 15. So that way, again, I can really fluctuate. The thing is, you don't want to exceed 50%. That's kind of one of the big issues that this starts to have. So you can even see that there's some overlap even before that. So you kind of want to be aware of that too. So I usually like to try to keep it somewhere kind of low. Now we want to actually begin to extrude this offsetted mesh. So I'm going to go to Transform now. I'm going to do Weaverbird Mesh Thicken. So I'm going to take that same thing, and now I can begin to offset it. Again, I can look at some of these parameters. Again, I'm going to stick with the 0 value and stick with something pretty low, so like 0.25. So I don't want it to be too thick. I'll turn this off so there's not a whole lot of texture clipping. So now we have something around that. So I'll just keep it nice and clean at 0.5. So now you can start to see how we get that thickness. Now the next thing is we want to add that smoothness to it. So now we'll go to Subdivision, and we're also going to do this first component to smooth it out. The only thing you really need to mess with that is the levels, which it maxes out pretty much at 3. So I'm just going to do quotation marks 3 because I don't actually want to adjust this at any point. And you'll also see that the other setting that comes out of this is whether you want it fixed, smooth, or corner. It defaults to the smooth. That's really kind of why you use that. So it kind of does that as a default already. But now you can kind of see that our surfaces are nice and smooth out both vertically in that extrusion as well as some of these areas. So we really kind of lose that very hard edge, which is great. The other thing we want to do is that we think this is, again, it kind of implies it by having a picture frame or a window frame. So we can also create our mesh windows as well, which is going to use pretty much some of these exact same parameters. So again, I'm going to use this part. It's asking for, again, the distance of offsetting this. You can use this one. It gets a little bit close when you start to apply some of these other changes, so just be aware of that. We don't need to thicken it, which is nice, but we also want to smooth this, so I'm going to also include that into there. So like I said, you can see that they don't exactly match perfectly. There is a little bit of a gap. And so what I'm going to do is just have a slightly different slider for that one. I do want to have some overlap of these. Oops. And then the next thing I want to do too is make sure that I have them actually kind of intersecting or somewhere at that midpoint, so that way they're actually more of a window or a glass plane instead of this plane that's on the inside. I want it actually kind of in the middle. So I'm also going to take this and move it in the Z value half the distance of this extrusion value. So I'm going to just drag that into there, and you'll see that that pretty much just moves it to the top. So I'm going to give this an expression and do x divided by 2, or you could do x times 0.5. Either way is going to give you half that distance. And you can see that there's not much overlap, so if you're really kind of concerned, you can always decrease this value until they intersect a little bit more. So that's how you can do that. Okay, so now we pretty much have our form now. We've got our actual frame and the glass. So the next thing I want to do is actually merge these two things together. So I'm just going to go to Sets, Tree, and Merge. So I'm going to combine both of those. They should pretty much give me the same data. I guess I can go ahead and flatten them just for simplicity's sake. So now I want to actually start to morph these things onto this surface. Okay, so a couple of things we just have to be aware of for that is that we're going to go to our transform component, go to morph, and do surface morph. So it's asking for what's the geometry you want to deform. That's this guy. It's asking for a reference or a box. And so all you have to do is create a bounding box for this. So I'm going to do bounding box. And you want to do it not per object, but rather union box. It does it for both of those. So now I can drag that into there. I'll turn that off. And now it's asking for the surf to map onto. And that's going to be this swept surface. So I'm going to plug that into here. I'm going to do one more thing. I'm also going to reparameterize this. This is what's going to allow us to have it pretty much map directly to it. And in order to get that to work, I want a number slider of 1 for both our U and V, because we've taken that parameter dimensions, which if we look at it, come out to 61 and 53. And by reparameterizing, it basically just scales that down to be 0 to 1 in both directions. So that's why we use this UV value. That swept surface doesn't have any thickness. So you can see we don't actually have any dimensions for that. So what we use for our W, or basically our Z value, is the same thing that we use for this extrusion. So I can just go ahead and drag this over to here. Now I can turn this off, and voila, now you have that surface morphed to that swept surface. So pretty easy to get there. I do want to show also again where we can add or make it so that we're including a little bit more parameters to this. You can see too here that there is quite a bit of overlap. In this case, if I were to kind of increase it that way, you can see that we can affect how much the glass windows intersect with the actual frame itself. And again, you can always start to play around with that pattern too by going to the Voronoi one, so where we have our Populate Geometry, and we can keep kind of messing around until we enjoy or like that pattern that we get out of this. We can adjust how dense we want this. If we want there to be really big openings, we can do it like that. If we want there to be a pretty dense grid of a lot of points, make it look like Swiss cheese, you can have it start to look like that by increasing the value. So in order to get it to get to that other output, I actually do want to have a pretty high volume of random points. So that's pretty much it to get to that first one. So now again, I'm going to start to adjust these things to add a little bit more complexity to it. So I'm going to actually take everything that's coming out of that populated geometry and shift it over to give myself some real estate. So the first thing I want to do, and I'm going to go ahead and turn this off. And what we're going to start to do, it's going to look extremely abstract. So it's not until we plug everything kind of in here that we start to understand exactly what it's doing. But you can see that I'm going to use this to kind of help me understand the frame. And so I basically want to have a dense grid of points, or somewhat dense in the center, because I can then basically merge all those together but still have a lot of large openings at the edges. So think of like this as being, we'll kind of explain that too. Think of this part of our surface as being this side, this part of the surface being that side, and then this middle is the top, right? So it's kind of literally like it's been unrolled that way. So in order to get that, I kind of want to, and if you want, you could physically draw that. For this, I'm just going to simply do it in Grasshopper as well, so I don't have to worry about Rhino geometry and accidentally messing that up. So I'm going to go to Curve and do Curve, or Point on Curve, and I'm just going to use this planar surface to create that, which is nice. And I'm going to drag that to around 0.4 to get pretty close to the center on that side. Copy and paste, and add something over here. And now I'm just going to connect those points to make this basically axis, or axes. So from there, I can now do curve closest point to basically say, okay, look at all those points and attract them to that curve, and that's going to give me some distances, and I can use that to start to filter things out and create a different and unique pattern. So I'm going to take those distances and go ahead and turn this off. I'm going to remap them, use their own bounding box or bounding values. And I'm going to use that for a graph mapper. Oops, over here. Okay. And I'm going to make this a Bezier one. Again, it doesn't matter. You'll see that you can just start off by having an S-curve. And the next thing I'm going to do is an operation to pretty much begin to track these, to pretty much find a middle ground between all these sprawled ones and all these dense points. And so I'm going to go to sets, I'm going to do a random. I want to make sure that I still stick within the range of 0 to 1. And I'm going to use the same number of values that I'm using for here. So if I'm using 100, I want to make sure I have 100. And then again, I'm going to create a seed slider to adjust the outcome of that. And so now what I want to do is do math. And again, it doesn't matter if you do larger than or smaller than. I'm going to take these values and compare it with my random values. And that's going to create a pattern for me. So if I go to sets, list, dispatch, so here's my points, here's my pattern, I can turn that off, and I'm going to now see what this looks like at the end. So I'll turn this off as well. So you can kind of see the way this is done is that it's kind of only looking at points away from it. So if I actually make my S-curve more like this, now I can start to mess with the density on the center. You can start to adjust it this way. Maybe you want to, again, kind of have a couple more out there. Start to do it like this. So it's one of those things, again, like most likely you want to have a lot more points than just 100. So I'm going to really crank that up to 500 to have a little more level of density to this. And then I can use that graph mapper to really adjust it. So now I can kind of really play with it that way. So I can kind of see if I drag it this way, it kind of keeps those points. If I drag this over, now I get more of kind of a concentration of points that way. So I just want to kind of keep fiddling with this until I get kind of a desired output of that. And again, this is where it's a little abstract for my liking to keep messing with that before I do my next step. So what I want to do now is actually create my Voronoi from that. So I'm going to go ahead and turn this on. I'm going to we'll keep it. It should be okay. So I'm going to drag this into my new set of points and turn that off. And so now you can kind of start to see how that works in terms of the cell size. So you know what? That's pretty good. I'm kind of happy with that. If I want, I could always kind of adjust the angle or direction of my covering, right? So I can always kind of play with that and everything will respond nicely. Maybe this is a little bit less, right? So it's even more centered. So that's pretty good. But like I said, it's a little hard to kind of really truly understand how this is going to look till a couple more steps. So what I want to do now is both kind of determine which of these do I actually want to keep as an opening versus which ones I want to keep solid. So what I want to do is use this kind of dispatch because this is giving me a lot of or it can give me a lot of parameters based off of this pattern. Or no, actually I don't want to use that one. Sorry. I'm going to take these cells. Sorry, I am going to use this for my distance values. So instead of the list being my points, I'm going to use them for my distances. So basically saying if it's so far away, I want it to be treated as a window. If it's closer, I want it to merge into the ceiling. Yeah, no, sorry, but I also want a completely different pattern. So I'm going to take those distances. So yeah, I'm going to use A as my set of points. I got 75 and 75. So I'm going to take those distances, and this is where I create that operation. So I'm going to do, let's just start with smaller than, and I'm going to do something like 12. And so now I'm going to use, again, my sets, list, dispatch. I'll use less than or greater than that. I can turn this off. And I'm going to just keep giving myself a little more real estate. We're almost there. And I'm going to create a curve for both the A and the B so I can actually see what the difference is between the two. Because again, it's basically filtering it out to know which one's which. So I have this one kind of highlighted as my areas that are going to get converted into the ceiling versus which ones are going to left as opening. Again, it's kind of hard to see what that output is, so I'm going to just keep plugging along. I'm going to adjust this in a little bit. So like I said, I want to use these to create my new frames. So I can kind of turn these on to show you how that starts to look. And then I want to also use these curves to create my surface. So what I can do is take those, convert them into, let's try this, the Weaverbird. I'm going to make those also the window. Nope, sorry, I don't want to do it that way. I want to make those curves, create a surface out of them, right? And then I'm going to convert them into a mesh. So you can kind of start out to see how that opening begins to look like. So here's probably a good point where you can kind of continue to play around with this until you get, so let's see if I do a couple less. So maybe that's more of kind of what that outcome is that you want it to look like. So we've just reduced that to kind of have a little bit narrower, and then those are still a little bit bigger. You can again kind of continue to play with this on how you want that pattern to start to look as well, so that way you have some kind of variation in the window size as well. You can always reduce the amount if you want there to be a couple larger cells instead of them being like that. So again, you have a lot of ability to kind of create something very versatile looking. So, I mean, that's starting to look pretty interesting. I wish there's a little more breaking up, so let me just kind of mess around with this a little bit. There we go. So and then I'm also going to mess around my seed with this too. So that looks pretty interesting. I just don't want there to be too many of these kind of what they seem almost vertical. So again, it just takes some work to kind of fiddle around with it so it's not too symmetrical or too kind of rigid. You want it to have that kind of organic feel to it. But anyways, I'm going to take this now, and now I want to actually merge these two together. So I can go to my utilities and do mesh join, and I'm going to plug these into both of there. I'm going to go ahead and flatten it to make sure that they're all in the same data branch, and you can see that now I just have one mesh coming out of that. And that's where I can now thicken that. So now when I turn this on, you'll see that now my surface is kind of merging with that. Same thing with the other parts, it starts to smooth it out, right? And so we also want to just make sure too that we have the same windows. So the ones that we're using to create these openings are the same ones that we use to create our windows, because we don't need windows in that part. So now I'm going to drag that one over to here. Can turn that off. We can see what it looks like merged, right? So again, windows, walls, and now the fun part, showing what that looks like as a morphed surface. And there you go. So again, you can kind of start to play with how much of a ceiling you want by continuing to play with this kind of graph mapper and the density of these things. So it's always kind of very adaptable, which is great. And again, it's not requiring a whole lot of computational pattern to play around with some of these ideas either. So that starts to, again, kind of get you to these different outputs and having quite a bit of variation as well. So I'm going to keep it right around there, and that looks good. So there you go. That's how you can create this Voronoi tunnel, so to speak.